Good morning and welcome to the Efficient and Distributed Training with TensorFlow training course at CSCS. I hope that you had a nice travel to Lugano, and so we are very happy that there were so many people interested in the course. So we decided to do these two topics that they may seem a bit disconnected somehow, but the main goal of the training is to get you started with using TensorFlow on an HPC facility, in particular on Piz Daint. And we are going to do like this. So today we are going to, it's going to be about, in a second, about input pipelines. So we're going to learn how to correctly feed data into models, and how to do it in such a way that we take advantage of the GPUs of Piz Daint, in such a way that the GPU is never idle. So we're going to try to make the most of it. And so we are going to see in detail just in half an hour or so. We will start. And so this is going to be today, mostly. And tomorrow we are going to do the part dealing with synchronous distributed training. And we were going to use mainly Horobot, but afterwards we are going to introduce some other implementations of the same algorithm that you can choose if you like. Oops. So before starting, I want to make a comment in which TensorFlow we are going to use. I don't know if you have been aware, last week TensorFlow 2.0 was released in an alpha version, which is still under development, and they suggest you, if you want to use it, just be careful and so try and test everything, because it's not completely ready. But it brings many good things. They are going to, this is already happening, but this is going to be on, by default, working, eager execution. So we no longer, you no longer will have the deferred execution of TensorFlow, but it will be an imperative that you execute a line and you get an output at the moment. There will have a refactorization of the code, which is going to be very good, because they are going to remove many duplicates on the codes and redundancy. And the input pipelines, we're going to talk about this in detail later, but this is going to be an important point of TensorFlow 2, and well, of course, here. And they will also start supporting the high-level APIs with Keras and Estimator API, and then the very primitive functions and APIs like layers of TensorFlow, they are going to be more like backends, and most of the things you will be doing it with Keras or with Estimator. And in this course, we are not going to use the TensorFlow 2.0, of course. We're going to use so 1.12, which is one of the latest versions. The latest one is 1.13. That is just minor changes comparison with this one. And we are going to do all the examples and everything using Keras and estimators. So everything that we will learn, in some point we will try it with Keras, and we will try with estimators. We will show also how to use low-level APIs, but it's not going to be the most important part. And so let's go. I'm jumping. Sorry, anytime I click, I just jump to. Okay. Now, before the agenda, I forgot to introduce myself and the other instructor today. My name is Rafael, and Guillermo. We work in the user engagement and support unit, specifically in the compute and data service support group. And so we are dealing with all the part that has to do with support, data science. Also, we are doing containers, continuous integration, if some of you use it, and Jupyter notebooks at CSCS. And so that's it. This is,
can we do the round of introduction now?
Go to the... so today, as I say, we're going to work with the input pipelines only, and we're going to do a bit interactive. So there will be a long talk for during all the day, but we will be interrupting it time to time. Each time we learn something, and we're going to do hands-on, and you will have the opportunity to work with everything we are talking here. And so lunch 12, we have coffee breaks, and that's it. And tomorrow. Sorry. And tomorrow it will be about distributed training, as you already know. We will start with some refreshing of the stochastic gradient descent in the regular algorithm, and we will play a bit with it, and then we will introduce the distributed asynchronous gradient descent. And more or less the same. We will have talks and many hands-on, and yeah. And now also this is being recorded, so the questions, maybe we will pass the microphone to ask, or if it is something very short, you can just say it, and we can repeat it, and just it is recorded. And now we would like, if you want, we would like to hear about you, what kind of things you intend to do with TensorFlow, and a bit about your research, if you agree.
So this is just 1 minute introduction, not even 1 minute. Just tell us where you come from and which area are you trying to apply TensorFlow.
So my name is Derek Feichtinger from Paul Scherrer Institute. I'm the group head of the HPC and Emergent Technologies group at PSI. We mainly provide the infrastructure, but also are going deeper into beginning to use these kind of environments. So we're still at the start in our group.
I'm Spencer Bliven. I'm also in Derek's group at Paul Scherrer Institute, and I'm particularly interested in biological applications, bioinformatics.
Hello, I'm Marco Bacci from EAVAG, and I have been developing a software to do data mining. It's uncertainty quantification software. I don't use any machine learning or TensorFlow yet, but I'm interested to learn it to see whether I can apply it to my problems.
My name is Irfan Khan. I am from Aalto University, Finland, and I am interested to apply TensorFlow and stuff in bioinformatics applications.
Hello, I'm Minsu Kim, and I'm from EMPA. I'm working on using machine learning to downscaling the satellite image of NO2 to the ground level. Yeah, that's what I'm working on. And I would like to use TensorFlow for this. Thank you.
Hello, I'm Haiyang Liu from ETH Zurich. I'm working on molecular dynamics. I would like to use that method to train some potential to use in the real simulation in physics and chemistry. Thank you.
My name is Jonathan. I will soon start a PhD at EPFL working with Meteor Swiss, and we want to use TensorFlow to better understand precipitation dynamics and downscaling, super resolution. Voilà.
Hi, my name is Tomasz Kacprzak. I'm from ETH Zurich, from Physics Department Cosmology Group. For a couple of years now, we've been introducing machine learning into cosmology, and we're working on applications of particularly deep learning for measuring cosmological parameters from the data.
Hi, my name is Sichen Li. I'm also from Paul Scherrer Institute. I'm working in accelerator simulation group, and we are trying to use machine learning to detect and prevent machine interruptions.
Yeah, hi everyone, my name is Adele. I'm at ETH working in atmospheric physics, and I would like to apply TensorFlow and machine learning to climate statistics.
Hi, my name is Marlon. I'm from the University of Zurich, from the finance department. And recently we started using deep learning to compute equilibria for economic models.
Yeah, I'm Alexander Grava. I'm from ETH, Institute of Geophysics. And we also we would like to apply machine learning for space weather forecast and for fluid dynamics applications.
Hi, I'm Behnam. I came from Basel University, computational physics group. I use machine learning and TensorFlow for atomistic simulations.
Hello, I'm Feng Wang, and I'm from IMPA in electron microscopy group, and my interest is applying deep learning in the field of electron microscopy, and especially focused on the solving inverse problems with deep learning, and I have been on this for about 2 or 3 years.
Hey, I'm Trun, also from EMPA, same group as Feng. And yeah, I can also mention that we're trying to do denoising of electron microscopy data and also 3D interpretation from the 2D images.
So my name is Antimo Marazza. I'm a final year PhD student at PFL, and in theory simulation of materials, and we work a lot with workflow automation, high throughput calculations, and first principle simulations for discovering novel materials. And we would like to use machine learning on the simulations data we produce to speed up the whole process.
Hi, I'm Freyr. I'm a PhD student at the PFL, and I've been using TensorFlow to do geometric deep learning on protein surfaces to analyze them.
Hello, my name is Pascal. I'm from ETH, from the Computational Science and Engineering group. We try to combine high-fidelity fluid dynamics simulations with machine learning. My particular interest is fish schooling, so we do simulation of fish and try to understand why they school and what kind of effect leads them to do that.
Hi, I'm Martin. I'm same group as Pascal in computer science and engineering. So I'm using TensorFlow in conjunction with fluid data to try and either do fully data-driven predictions or replace parts of solvers with machine learning submodules.
Hi, my name is Shoshana. I work at CSCS in the Scientific Software and Libraries unit, and my work is in how to apply machine learning to HPC. So how can we use machine learning to automatically optimize programs?
Hi, I'm Shruti, and I'm coming from ETH Swiss. For now, I have limited exposure to machine learning and TensorFlow, but plan to use it in weather prediction, particularly thunderstorm forecasting.
Hi, my name is Robert Feldman. I'm a professor for computational astrophysics at the University of Zurich. I'm exploring options of using machine learning approaches, including TensorFlow, for classification problems in my research. Since I have the power of the microphone, I would also like to ask the organizers, do we have access to the slides? Can we get the slides during the lectures?
Yes,
I think it would be very useful. Okay, thanks.
Hi, I'm Robert Verbeke from University of Zurich as well, Institute for Computational Science, and I've recently started using TensorFlow and Keras to study galaxy formation.
Okay, thank you all. It's very nice to see that there are so many applications, and also that we're happy to see that there are different stages of people that are already using it and people that are starting. We will try to keep it just in the middle, accessible for everybody and not boring if you already have used it. And yeah, now Guillaume is going to show you how to get started on Piz Daint, how to log in, how to access everything. And in the meanwhile, I will try to put the slides available for all of you.
Okay, so I will just give you a brief introduction on how to use TensorFlow on our system. So the idea is just to give you an overview of the possible ways of obtaining TensorFlow, since this can be a complicated task and the results can vary a lot. So we are going to present the different ways that we tried so that you at least have this background and you don't need to do it yourselves, the same things that we did already. And then after this overview, I will just start distributing the students' account. So we have a reservation on Piz Daint for the course. So even if you are a CSCS user, you should be using our reservation because of the access to the Jupyter Hub interface. So we have limited nodes in the standard Jupyter interface. So if you use your regular account, you might not find nodes available. So the idea today is that everyone, in this session, is that everyone can access the SSH with your student account and then using the Jupyter Lab interface as well. So the most common way of obtaining TensorFlow is just to download the binaries. So this it's very easy to install, and recently they have moved to also the support for newer architectures, so it can also perform well. In the past it was not the case, and then you have the options of using either PIP or Conda, whatever you like. And of course this works very well in your laptop. In a HPC computer it might not be the best, but still it is an option if you want to try newer versions, and we still didn't provide here, for example, at CSCS, the release cadence of TensorFlow is quite fast. I think you already noticed that, and sometimes Raphael can also go on holiday, so we might not find the latest version on Piz Daint, so it gives you an alternative meanwhile. The other good option that we advise users to try, especially on their laptops, but now we are also giving more and more focus on containers in the HPC systems, is the usage of Docker images. So you can simply get the latest from the official image from TensorFlow and just use it by just using a Docker pull, and then you have it in your laptop. And if you're using an HPC system, of course, you cannot use Docker for security reasons. So we have currently Shifter NG installed. In the future, so that you are aware, Shifter NG is being discontinued. We are moving to Cerus. So that's the module that you're going to see from now on very soonish. I don't have the date, but very soon you're going to see Cerus instead of Shifter NG on our supercomputers. And then you have a similar command line interface to download the images instead of Docker pull with Shifter pull. And if you look at the documentation, it's very similar to Docker. So if you are comfortable with Docker, you're going to be comfortable with Shifter NG/Cerus. The other option that we also are testing right now is to use the NVIDIA cloud, so NGC. They spend a lot of time optimizing images, and we also noticed that the performance of their images in general, this is not only for Singularity, but their container images usually are very well optimized, so they are competitive also on our systems. The caveat here is in general is that the MPI support is not compatible with Piz Daint, so we cannot use for other kind of applications, but for deep learning applications and applications that don't use MPI, it is also an option. So we are still working on the problem of the MPI compatibility, and maybe at some point we are also going to support these images in the sense that you could just download any image from NVIDIA Cloud on our systems, and we will provide the ABI compatibility to our MPI layer. Anyway, this is a bit out of context for TensorFlow because you use other backends and not necessarily MPI. So all these binaries, they need to come from somewhere, right? Someone needs to be building. You cannot just have everyone using the binary. Someone needs to build, and we are doing that effort here at CSCS. Also to make sure that the performance of our builds is competitive, we need always to compare with the state of art and the other containers. So we still build the TensorFlow from sources. I'm just giving the main things that you need to look if you plan to do that. So if you're just playing around in your laptop, you probably don't care about having the best performance possible. But if you're running large-scale simulations, you might care about to use all the instructions available on your architecture. So you should at least try to build ONS to compare the results. And the main things that you need is, of course, Python, Basel, which is the build system from Google. And here, what needs to be taken into account is that Basel also provides all the dependencies inside their workspace. So it should be self-contained, but in practice, it is not. So we still need to install other dependencies, such as protobuf, and they need to match with what Basel is using inside. So you need to be careful when choosing the versions of the dependencies. These are the three main steps when you plan to build the TensorFlow. So the first is a manual interactive configure script. So you run a bash script and you start answering questions about the location of your software. So this is very bad for automation. So if you're going to see our automated scripts, they are very complicated because of this. They don't think about automation, or they do it in a way that only they know how to do it. So we need to work around that. And these are the main flags that you need to be careful. I point this out because of the instruction sets that they need to match your architecture to make sure that you're using everything from what your system has available. So AVX2 and so on. And this build command will actually just generate a wheel, a Python wheel, and then you can just install the wheel with pip. So how do we do that? Of course, that cannot scale here at CSCS. So we cannot just be, every time there's a change, we spend the hours tweaking and manually doing build steps. So what we use here is EasyBuild. We have the EasyBuild framework installed, and is also available for you. So what we do is that we prepare automated recipes that will automatically fill all answer the questions and eventually patch the things that cannot work out of the box. And these recipes are available also for you as users. So you can search for the recipes, and if you need a new version or a different flag, you don't need to tweak with all the options. You can just take one recipe and change the flag that you need, and you can build with using one command line the whole TensorFlow package, including the dependencies. So there are dozens of dependencies that are needed. So in one command line, you can do everything, which is the EB TensorFlow and then -R. This will take care of installing everything on your prefix folder, and will create a module file. So you can just do module load of the new installed TensorFlow if you need. So this is a general remark about performance. So I'm really stressing this part because sometimes we have people using binaries that they don't match the architecture, and this is quite a waste of resources. It is okay for small tests, but once you're running production work on large-scale system, you need to always make sure that your build, your binary matches your architecture. You might not see at first if you run a small benchmark, but for example, if you change the usage of the CPU and GPU ratio, and you're going to be using more the CPU at some point in your code, then you're going to see that the AVX instructions missing will make a difference. For the GPU part, generally is not a problem because generally the binaries, they are not fat binaries, but they have the instructions of for many different architectures of NVIDIA devices. So for the GPU part, usually if it's a recent build, you don't have a problem of if you're using older architectures or newer architectures. Only if your build is your binary is really too old and you have a newer GPU, then you might not use everything that you have available. So just to give an example about what can happen with PIP and what happened before. So before TensorFlow 1.6, you didn't have AVX instructions by default. So the focus on these generic binaries is that should be portable. It should work everywhere. And not always they care about the performance. So this is something that you need to be careful when you're using. So since 1.6, I would say the difference is not so big. We don't see the difference between a manual build in the current architecture. That of course can change as soon as you move to a new architecture. But on our systems right now, we don't see the gap anymore. And actually, Rafael mentioned that with Anaconda, you have a slightly better performance in some codes than comparing to PIP. And so right now it's the time for distributing the accounts. Before distributing the accounts, I would just give you a short overview on how to access the systems. You are users, so you probably know that already. I won't spend time. This is just so that you know that before going to Piz Daint, you need to SSH to the front end, and now you need to use your student account. So I'm going to distribute the accounts. Rafael will give you the path to the slides so that you can also have the slides while you work. And in the same path, we are going to distribute the Jupyter notebooks for today.